So there's two levels. There's rookie and veteran. And so you're a rookie and your first task is you have to develop an ROV and it has to retrieve a T that's underwater.
This is the very first time we call them rookies. This is their first time through this really design, revision, explore project. Then when they repeat the class, which is something you can repeat and you amp it up to the next level, you found out really how limited your first design is and how to make it better to go deeper, farther, last longer, bring you better video, or manipulate something below the surface of the water. The veteran members, as they return, choose really a specialty area, whether they want to work in additive manufacturing or explore circuits or explore video, many different aspects, whatever they really are kind of interested in or wanting to improve, they start to focus on that end of the high-tech ROVs and they specialize in that. And then they take these ROVs and work with the entire team to develop a product that's beyond what any of them could come up with on their own.
Maybe we could add something like in the, I don't know. Because if we add
Yeah, but when it goes backwards, I think the reason that it goes like that is because we don't have noodles in the bottom at all.
Yeah, but we don't want the bottom to float.
Yeah, but
It's problem solving where the problems are no longer made up by the teacher. The instructor, the teacher, hasn't removed the nuances, the tricky things, the hang-ups, where all the ugliness stays with the problem as you work it through. And that also what makes it so much more exciting. The answer is, I think this, and I'm going to make it and find out if it really is that.
Yeah. It goes like this, and then it goes like that.
Have push on it like it's going to go backwards. Push on your robot from where your motors are to where it's going to go backwards. Where are your motors located? In the bottom. So the water's pushing here, 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 here. Whereas you only push the other way.
Okay.
The student, for the first time, is exploring something where the answer that the student works to come up with can only be checked by implementing that answer. How would you remedy that problem? When I look at how we actually conduct the learning that happens in the classroom, we put this challenge forth and the students choose to engage in this challenge with, like I said, the ugliness that goes with the problem. We didn't pull out the tricky things we might think would be too hard for the kids. And so as they start to come up with a solution and they think they have the answer and they're sure it works, they now put it in the water. They take their main idea, their answer, and they throw it in the water and it doesn't work. It fails, it leaks, it explodes, it burns up, and they have to try it again. They made this huge mistake and they're momentarily devastated. But with that devastation comes a spark where I think I know how to fix this. And that drives their learning, and that's what drives them to the final solution that really does solve their challenge.